What's up, everybody? Welcome to some chemistry about Lewis dot diagrams, which are sometimes called electron dot diagrams. Now, these go along with those electron configurations and orbital notations we were talking about over the last few days in classes. And what we're doing here is we're going to use the orbital filling or the electron configuration. We're going to use the abbreviated one, the one with noble gases, and that orbital rotation. And we're going to draw dots equal to just the s and p electrons. All right? Which means we can never have more than 8 dots around our atom or around our chemical symbol. We're only looking at the s and p electrons because these are in the highest energy levels. All right. Now, even though like a 4s electron gets filled in before, or a 4s orbital gets filled in with an electron before the 3d orbital, the 4s orbital electron is still in energy level 4. So it can get kind of confusing if you really start to look at the electron energy nature and get really deep into the weeds, but we're going to leave that to the quantum mechanics experts. And we're just going to talk about electron dot diagrams, Lewis dot diagrams that involve just the s and p electrons. So this means there will never be more than 8. And really, it's a pretty easy thing. You can use your periodic table. There's a couple of shortcuts that I will show you in a little bit. But we're going to do the electron configuration, orbital filling, and Lewis dot for the element selenium. So if I was trying to find selenium on the periodic table, selenium is right here, element 34. All right, it is right below sulfur and oxygen in group 16. If I look at element 34, I go up and to the noble gas. To start my abbreviated configuration, what I find is that argon is the noble gas in the row above selenium. So again, here's selenium, up and over, there's argon. After argon comes the 4s orbital, and there's 2 elements, so 2 electrons there. So we get a 4s2. Then we move on to the 3d orbital. There are 10 elements there, none of which are selenium, so we get 3d10. Remember, each element adds an electron. And now we get to the 4p orbital, which is the orbital block that selenium lives in. It is 1, 2, 3, the 4th one there. So we end up with 4p4. To do the orbital filling, I need to draw one box. That's my 4s. I'm going to draw 5 boxes that are my 3d, and 3 boxes for 4p. I then go in and I use the exponents here, these numbers, to identify number of electrons in each orbital. Make sure I have my orbitals labeled. Well, 4s had 2 electrons in it, so it gets an up arrow and a down arrow. 3d has 10 electrons, 1, 2, 3, 4, 5. Remember, they half fill first, and then they fully fill up. 3, 5. And 4p has 4 electrons. We half fill each box. And then this 4th electron can really go in any box you want. It doesn't matter which one. it teams up with one of them. I always do the first one because it comes first, but it does not have to be the first one. I could have put it in the middle one. The new part is the Lewis dot diagram. Lewis dot diagram, super easy. I take my symbol for selenium, which is Se. I add up my number of s electrons plus my number of p electrons. In this case, 2 plus 4. I shouldn't need a calculator for this. 2 plus 4 equals 6. I put 6 dots around Se. And I do 1 dot at a time per side. 1, 2, 3, 4, 5, 6 dots. And that's my answer. All right. There are a couple different schools of thought and ways you can look into doing the dots around the symbol. Different chemists and chemistry teachers might tell you slightly different things depending on what level of chemistry you're at. For this level, this Gen Chem class, for you guys in high school, I'm just looking that you have 6 dots, right? Each side should get no more than 2, and you get 6 dots total. All right, so there you go. We'll do another example on the next page. All right, here's our next example. Our next example is the Element Technetium. All right, and we're just going to use our periodic table to find the electron configurations. You could also Google the electron configuration, but that's not going to help you on a test. Because sometimes they change and vary slightly, especially with D and F electrons. Sometimes weird stuff happens. But anyway, there's technetium, solidly in the 5th row of the periodic table. All right, in column 7, right under manganese. For the abbreviated electrode configuration, I find technetium. I go up and zip all the way to the end. I got krypton as the noble gas in the row above. So, first thing I do is I go in and I put krypton in brackets. Now I go with what I see after krypton. After krypton comes the 5s orbital. There are 2 elements there. So we got 5s2. After that 5s orbital, as I move over, I get to the 4d orbital. And technetium is the 1, 2, 3, 4, 5th element in 4d. So it gets 4d5. There's my abbreviated electron configuration. I have to now draw the orbitals. Well, 5s gets 1 box because all s's get 1 box. 4d gets 5 boxes. 2, 3, 4. There's my 5 4d boxes. Now I go in and I put in my electrons. 5s had 2 electrons in it. 4d had 1, 2, 3, 4, 5 electrons. Remember, the electron fills an empty box before it teams up with another box. All right, they don't mind existing in the same box in pairs, but they would rather have their own box first. And then for the electron dot diagram, or the Lewis dot diagram, I go and I find all the S's and P's. Well, in this case, there's only S electrons in the abbreviated configuration. There are 2 of them. So I go in, write my symbol for technetium, which is Tc, and I get 1, 2 dots. All right, and again, you can put the dots next to each other or you can separate them out. I like separating them out, doing 1 dot per side once, a 2nd dot per side a 2nd time. There are several schools of thought on how you can do this. I'm just looking for your symbol with 2 dots at the end, and that is how to find the the electron dot diagram, the Lewis dot diagram of technetium. Alright, I got one more example for you here, and then I'll give you a quick little shortcut for the periodic table and electron dot diagram. Alright, first off though, we have Mendelevium. Why Mendelevium? Because it was named after Dmitri Mendeleev, the guy who made the table. He would have hated this stuff because he did not like the concept of atoms, let alone electrons, even though he didn't really know about them. I don't think he would have liked them. Anyway, here's Mendelevium, element 101, down in that little 5F block, one of those F blocks at the bottom. Alright, the tricky little F'er blocks at the bottom, they're way down at the bottom. Alright, so Mendelevium. What is the noble gas in the row above them? Well, you might think to put Yb, which is ytterbium, in there, but that's not really the noble gas in the row above Mendelevium. No, Mendelevium is in this little double asterisk box here that I'm highlighting now. So it's part of period 7, or row 7 on the table. You can see it reminds you of that right at the beginning of it. And so then, if it's part of row 7, I got to go up into the end of row 6, and I see radon is the noble gas in the row above. So I'm going to start off with radon. And after radon, we get to that 7th row, and there are 2 elements in 7s. So we get a 7s2. Then we get our little tricky box that shoots us to the F's at the bottom. All right, the bottom row of F's is the 5F's, and Mendelevium is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 13th element in that row at the bottom. And remember, that row is 5F13. Now, if you Google this, you might see it say 7S1, 5F14. It might be one of those tricky ones. Probably depends on where you find your information. If you're grabbing it just off the periodic table like this and predicting it, this is what you would probably come up with. This is what I'm going to go with. I'm mainly looking for your orbital filling and your Lewis dot. Does your filling match your abbreviated? Does your Lewis dot match your abbreviated? So if I was doing this as orbital filling, I got a 7s. S gets 1 box. 5F gets 7 boxes. 2, 3, 4, 5, 6, 7 boxes. According to my abbreviated configuration, I have an up and a down in 7s. And I need 13, 2, 3, 4, 5. Half fill first. 6, 7, 8, 9, 10, 11, 12, and 13. Alright, so there's only one opening here, and so on. So, now I'm going, and I'm trying to do my electron Lewis dot diagram. There are 2 s electrons, so it is only going to get 2 dots. Mendelevium is MD, and 2 dots. And what you'll see is most of the elements, when you do it this way, end up with 2 dots. But there's a little sneaky trick on your periodic table if you're using the one that looks like this one on this video. All right. In each column in the S and P block, there are numbers in parentheses. Those are the number of valence electrons. Those are the number of dots for everything in that column. It makes it really, really super easy for all of those. All right, so these highlighted things, I need a pen. These highlighted things equal the number of valence electrons, or dots, if that makes it a little easier for you. Everything in the middle of the table, all of these that have the B's, all of these in that big D block right there, and then everything down here at the bottom in the F block, all right, they don't have any p orbitals. All right, so all this highlighted yellow stuff, we can treat it like there are two valence electrons, or dots, if it's easier for you to remember the word dot. All right, and this works almost all the time. Like I said, there are some weird electron configurations that happen in the D block and the F block, but we're not really going to worry about those or anything. So that is how you do like this electron stuff, and these are types of questions you might see on your electron unit test. All right. If you have any questions, as per usual, you can talk to me if I am your teacher. You can go talk to your other teacher if it is not me. All right. Thank you very much, and have a good day or night or whatever time it is.